Hey everyone, welcome back to the channel. Today we're diving into data transfer instructions in computer organization and architecture. This is a fundamental topic that every computer science student needs to master. Let's get started. So what exactly are data transfer instructions? Think of them as the movers of the computer world. They don't create or modify data, they simply move it around, from source to destination, through an instruction. This happens constantly inside your computer, billions of times per second. Data can be transferred between three key locations. First, we have memory, where all your programs and data live. Second, registers. These are super fast storage spots right inside the CPU. And third, I/O devices, your keyboard, mouse, monitor, printer. Notice how they're all connected? Data flows between all three constantly. Let's zoom in on memory and registers. Memory is like a giant warehouse with addresses. See these hex addresses like 0 by 1000? Each one points to stored data. Registers, on the other hand, are like your desk, small, but instantly accessible. You've got the accumulator for calculations, data register for temporary storage, program counter tracking which instruction comes next, and I/O registers for device communication. Now let's talk instructions. Move is your Swiss Army knife. It can copy data in three ways. Register to register? No problem. Register to memory? Sure. Memory to register? Absolutely. The cool part? Move doesn't delete the source. It copies. And depending on addressing modes, this one instruction has 7 to 8 different variations. Here's move in action. Example 1. Move R1, R2. This copies whatever's in R2 into R1. Example 2. Move R1, 500. This puts the number 500 directly into R1. That's called immediate mode. Example 3. Move R1, X. This grabs data from memory location X and puts it in R1. Same instruction, 3 different jobs. Load has one specific job. Bring data from memory into a register. See the green arrow? It's a one-way street. You can load from a memory location like load R1, X, or load an immediate value with load R1, number 500. Either way, you're pulling data into the register where the CPU can actually work with it. Store is LOAD's opposite twin. It sends data from a register into memory. Notice the orange arrow going the other way? When you're done calculating something, you store it back to memory so you don't lose it. Example, store R1Y. Whatever's in R1 gets saved to memory location Y. Exchange is the swap master. Look at this. R1 has 100. R2 has 200. After XCHG R1, R2, they've switched places. R1 now has 200. R2 has 100. This happens simultaneously in one instruction. Super useful for sorting algorithms and data manipulation. Input and output connect the computer to the outside world. Input brings data from peripherals like your keyboard into memory. Output sends data from memory to devices like your monitor or printer. Every time you type a key or see pixels on screen, these instructions are working behind the scenes. Now for something special, the stack. It's a LIFO structure, last in, first out. Think of stacking plates. The last plate you put on top is the first one you take off. Item 4 is on top, and it'll be the first to come out. This structure is crucial for function calls, temporary storage, and recursion. Push and POP work with the stack. Push adds data to the top. See that orange arrow going down? It's bringing a new word onto the stack. POP does the opposite. That blue arrow going up? It's taking the top word out. Together, they manage temporary data beautifully. Every time a function is called, push saves the data. When it returns, POP restores it. Set and clear are simple but powerful. Set puts a 1 into a register, like flipping a switch on. Clear puts a 0 in, flipping it off. These are often used for flags, initialization, and bit manipulation. Quick, simple, essential. Let's recap everything with this reference table. Move copies data anywhere. Load brings in, store sends out. XCHG swaps. In and out handle peripherals. Push and POP manage the stack. Each instruction has a specific job, and together, they make your computer work. Here are your key takeaways. Move is the most versatile. Use it everywhere. Load brings data in. Store sends data out. Remember the direction. The stack uses LIFO with push and pop. And addressing modes determine exactly how these instructions execute. Master these concepts, and you'll understand how data flows through any computer system. Coming up next, arithmetic instructions. We'll cover ADD, sub, memul, div, and more.